In this section, we're going to go over equation of asymptote. Now, I abbreviate it as EOA. So that way you don't have to write out equation of asymptote or asymptote for short. Just simply write EOA if you were to do problems for my class. So keep it short as EOA. So let's take a look at example 1. Example 1 is m of x equals 6 to the power of x minus 2 and then minus 5. Now below, I gave you the corresponding graph, and here's why the asymptote comes in. So here we're going to be writing out the equation for the asymptote. Now the asymptote is where the graph, and again, this is going to be the horizontal asymptote. Later on, we're going to focus on vertical asymptote, but for this section, we're mainly going to focus on horizontal asymptote. So if I didn't specify before, again, this section, we're going to focus on horizontal asymptote. Keep in mind that in the next chapter, we're going to be using horizontal asymptote with vertical asymptote. But for this one, we're going to do horizontal. So the horizontal asymptote comes into play where the graph, if you look at the bottom of the graph for example 1, you see that it's going along the line at y equals negative 5. So as I stated in the previous section and previous example, if you were to zoom in closely, the graph doesn't actually overlap at y equals negative 5. It goes towards near it. And as you keep moving towards the left and you zoom in, you see a little gap between y equals negative 5 and the graph line. Again, as you progressively move towards the left, and you could do this on X amount of negative numbers, you can even go to negative 1,000. And if you zoom in, again, at negative 5 and the graph, there's going to be a little gap where it doesn't overlap. It's just that the graph goes towards negative 5. So, getting that out the way, since we established that the graph is going towards negative 5 but never reach, this is where our horizontal asymptote comes into play. So here I drew a pink arrow line and I circle at negative 5, establishing that that's where my horizontal asymptote is located. So asymptote is where the graph goes towards the line, in this case a horizontal line at negative 5 but never reach. So since that's where my horizontal asymptote is located, and it's located at negative 5, so for our equation, our EOA, it'll be written as y equals negative 5. And so that's all you have to write for EOA, equation of asymptote. Moving on to example 2, we have p of x equals negative 2 to the power of x minus 5 and then plus 3. So let's show you the corresponding graph for example 2. Now this one, since there's a negative in front of the base, the graph flipped vertically. So it reflected across the x-axis. So in example 1, we look at the bottom of the graph, but now in example 2, we look at the top of the graph. So as again, you see how at the top of the graph, it gradually comes close to y equals to 3. But again, even though it looks like it overlaps, but if you were to zoom in closely, you still see a gap between the blue graph line and the horizontal line at y equals to 3. So let me draw you my pink horizontal arrow line and circle at 3. So again, here I'm establishing that this is my horizontal asymptote. And again, as I stated before, if you were to zoom in, the blue graph line doesn't overlap at 3, it just goes towards 3. So my horizontal asymptote will be at 3. So therefore, for our final answer, for example 2, simply write y equals to 3. Now, let's take a look and compare between the two examples. Notice how for example 1, the EOA, y equals to negative 5, it corresponds to the minus 5 in the equation. So the last number in the equation. And then look at example 2, the EOA is y equals to 3. Again, it corresponds to the last number in the equation, the plus 3. So there might be a pattern. Let's take a look at the next two examples. So example 3, we have k of x equals to negative 8 to the power of x plus 1. X plus 3, and then the plus 1 in the back. So if I were to use the patterns I just learned from example 1 and 2, then I think that the EOA, the equation of asymptote, will be y equals to 1, which it is. If you were to graph this function, you can clearly see that there will be a horizontal asymptote at y equals 1. So using that pattern, let's try example 4. Example 4 is n of x equals to 7 to the power of x minus 9, and then minus 2. So if I were to use the same patterns, then I would look at the minus 2 for my EOA. So for my final answer for EOA would be y equals to negative 2, which it is. So therefore, that's my answer for equation of asymptote. So in terms of equation asymptote, if I go back to the graphs, so here's a horizontal asymptote. And again, if you look closely at the bottom of the graph and the top of the graph, if you were to zoom in, you will clearly see that it goes towards the horizontal asymptote. So for example 1, it goes towards negative 5. And for example 2, it goes towards 3, but it will never reach. Hence is why we classify it as horizontal asymptote. Now, again, using the patterns, for example 3 and 4, I just simply look at the last number to determine my EOA, equation of asymptote. So for example 3 plus 1 is the last number, then therefore my EOA is y equals to 1. For example 4, my last number is minus 2, therefore my EOA is y equals to negative 2. So make sure you have that rule down, so that way, again, you don't have to look for it, and for EOA, it's not much work, just memorize the rules.